Hey, this is Rob, aka The Pole, from Circle City Brewing here in Indianapolis. Just doing a video here today on my electric E-HERMS system, just to try to explain some of the components and try to get some quality video for a few of you guys who are actually trying to build this system at home. It may offer a little more detail as to how the system was actually constructed. So let's go out in the garage and take a look. First, we're going to start here with the electric boil kettle. This is just your standard 15.5 gallon Sankey stainless steel keg, of course with the lid cut off, and a half-inch full port ball valve here at the bottom. The bulkhead is a weldless bulkhead, and though some people have had problems with these leaking, I've never had a problem with mine in just about 2 years of use. You can also see the half-inch brass quick disconnect from McMaster-Carr that I use on the entire system as well. Taking a look inside here, you can get a look at the rotating dip tube in the bottom there. It's just a compression fitting that runs to that, and then the 5500 watt rip element that comes through the side of the keg. And if you can see the stir paddle I have here for the mash, I also have some holes drilled in it every half inch from 5 gallons all the way up to 8.5 to measure the amount of fluid in the keg when we're doing the sparge. We'll take a look at the outside here on how the electric element is attached. It just runs through the wall of the keg through an 1.25 inch hole that was drilled with a step bit, a titanium nitride coated high-speed steel step bit, and then it's just attached using a 1-inch straight pipe thread nut on the inside, and using the standard water heater element seal on the outside. The key here is to make sure that you hand tighten that so that you don't roll the seal. If you make it too tight, you're going to roll the seal, and you're going to have a lot of leaking. Below that, you can see the K-type thermocouple. It's only about a 1/4 inch long inside the keg itself. I've run a couple tests, and it works really well for determining the temperature of the fluid inside the keg when it's coming to a boil and when it's cooling. You can also see I have the ground attached to the keg at that same point. And on the inside of the keg, on the other side of the hole there's just a standard 1/4 stainless steel wing nut, so that can be removed easily if I need to remove the keg from the stand for cleaning. Right here we're taking a look at the mash tun. It's just a standard 10 gallon Rubbermaid beverage cooler converted to a mash and lauter tun. Right here you can see you've got a half-inch full port ball valve with a quick disconnect male end on there. All the hoses are female, and the ball valves and everything are male. The bulkhead that runs through the wall there, it's all half-inch components, and I detailed the parts needed for that on HBT and a thread that I started. Total cost for that was about $16 for each tank. Now you take a look up at the top here. We've got a half-inch diameter lock line from McMaster-Carr that's used for the E-HERMS return line and is the sparge line. I fly sparge this system, and it seems to work really well. Just using that lock line there, just keep below the level of the water in the tank, above the grain bed there while you're running the sparge. Inside you can see we've got a regular stainless steel false bottom, and on the right hand side you can see a through-the-wall digital thermometer. That's used primarily just to check the temperature of the strike water once it's cooled. I always strike with whatever the strike temp is, plus 10 or 15 degrees to preheat the tank itself, and once it reaches the correct strike temperature, then we mash in. Once again, it's a pretty simple build. It's just a gum stopper runs through the side of the tank there. It's a solid gum stopper, which is a small hole punched through it, just so you can squeeze the probe for the digital thermometer through. Right here is basically the heart of the E-HERMS system, the electric hot liquor tank. It's controlled by a Johnson A419 temp controller. You can see here. It's just secured to the outside of the tank with a couple stainless steel screws. It can be easily removed if you need to take it off the tank there, remove the tank for cleaning, etc. Inside we've got a 1500 watt, 120 volt AC electric water heater element to heat the strike water and maintain the temperature in the tank for the HERMS recirculation and for mash out. Up on the lid here you can see the inlet on the left, on the right hand side you can see the inlet for the HERMS coil and the quick disconnect there. On the left hand side you can see the outlet which runs to the mash tun lid. Right there you can see the AC gear motor which powers the impeller inside the hot liquor tank. That just stirs the water so we don't get cold spots around the coil since it is extracting heat from the water in the tank, or a hot spot right in the center near the water heating element since that's what's providing the heat. Underneath this little PVC cap here you can see my homemade stopper thermal well. It's just a regular drilled stopper with a 1/4 inch stainless steel corny keg dip tube, and that is crimped at the end. It's cut to proper length and crimped at the end, and then you can install the 1/4 inch thermistor from the Johnson A419 temp controller. And once again it also has the 1/2 inch full port ball valve with the bulkhead that I built from the parts listed on HBT in my own thread.